7 is all about the study of four-sided figures, which we call quadrilaterals. And in this first section, we're going to study a specific type of quadrilateral called a parallelogram. So you'll notice in questions 1 through 8, we have, actually 1 through 4, we have a parallelogram, and there are many properties of parallelograms. In question number 2, they're specifically asking about angle NML, which is this angle right here. Now what we know about parallelograms is that opposite angles are congruent. So angle NML is congruent to this angle here, which we call angle LPN. The second angle is angle MLP. MLP is this angle right here, and it is congruent to the angle opposite it, which is this angle here. We call that angle PNM. Another property of parallelograms is that the diagonals bisect one another. So, diagonal MP bisects diagonal LN, and diagonal LN bisects diagonal MP, which means it cuts the diagonals into two congruent parts. So segment MR is congruent to segment RP. And segment LR is congruent to segment RN. Now, because in this diagram we have a rhombus, and because a rhombus is also a parallelogram, the properties are true for a rhombus that are true for a parallelogram. So opposite angles again are congruent. So angle UVW, this angle right here, is congruent to angle UXW, the angle opposite. And angle XUV is congruent to angle XWV. Segment UE is congruent to segment EW. Because as in a parallelogram, the diagonals in a rhombus also bisect one another. And segment XE is congruent to segment EB. Number 10. We have a mechanism here that you've seen before in a bicycle. It's called a derailleur. And in this derailleur, there's a diagram showing a parallelogram. And we call that parallelogram JKLM. In this diagram, JK has a measure of 5.5. And KL has a measure of 2. ML has a measure also of 5.5. And MJ also also has a measure of 2. So to explain why JK and ML are always parallel. Well, because opposite sides are congruent, that means this figure will always be a parallelogram. Therefore, JK and ML will always be parallel to one another. Those distances will never ever change. Okay, once again, we're looking at a parallelogram, and what we know in a parallelogram is that opposite sides are congruent. So that means that this side of the parallelogram is equal to this side of the parallelogram. So I'm going to write an equation to help me to find W. 2y plus 3 is equal to y plus 9. Let's see if we can set up some space here to solve this. Also in this diagram in part A is we need to find the value of x. We know this angle is 4x. We know this angle is 2x. And one of the properties of a parallelogram is that consecutive or next door neighbor angles, angles that are next to each other, consecutive angles, in a parallelogram are supplementary, which means they add up to 180 degrees. So I can write an equation to help me to find x. And that equation would be 4x plus 2x together is equal to 180 degrees. Those two angles are supplementary. In part B, we can easily find y once again by setting 6y plus 10 equal to 7y plus 1, like we did in part A. The second part of this problem to solve for x is we notice that the distance from here to here is 3x, and the distance from here to here is 2x plus 10. Now what we remind ourselves about a parallelogram is that the diagonals bisect each other, which means that this segment is congruent to this segment. So an equation to help me to find x would be 3x is equal to 2x plus 10. In part C, remember that the opposite angles of a parallelogram are congruent, so therefore 3x is equal to 120 degrees, so x is 40. Replacing x with the value of 40, gives me this angle measure of 3 times 40, or 120 degrees. These two angles are supplementary angles. They are consecutive next-door neighbors, and in a parallelogram, those two angles must add up to 180 degrees. So one of the angles is 120. The second angle is 2y, and together they equal 180 degrees. So y is equal to 30. Number 14, we're looking at a special type of parallelogram, a rhombus. And what we know about the diagonals of a rhombus is that they are perpendicular to each other. So they all form right angles here in the middle of this parallelogram. So each of these angles is equal to 90 degrees. So an equation to help you to find x would be 3x is equal to 90 degrees. So x is equal to 30. So in number 16, we are going to do a two-column proof. And in this proof, what we are given is a parallelogram. So let's just take a look at this drawing. First of all, let me outline the parallelogram. This whole entire figure is a parallelogram. What we're trying to prove is that in this parallelogram, segment GL is congruent to segment IL, and segment JL is congruent to segment HL. And that's what we're trying to prove. We don't know that. That's not part of the given, but that's what I'm trying to prove in this proof. So my plan is, in order to prove that those two parts are congruent to each other, I'm going to prove that this triangle is congruent to this triangle. Now, if I can prove that those two triangles are congruent to each other, then I can say that all the corresponding parts are also congruent to each other. So let's start with our parallelogram and what we know. Okay, so once again, I'm trying to prove that this triangle is congruent to this triangle. So let's start with these two sides. Because this is a parallelogram, opposite sides are congruent. We have a pair of vertical angles right here. So far I have one pair of sides that are congruent, and I have one pair of vertical angles that are congruent. So I need one more thing to prove that the two triangles are congruent. And because we have parallel sides, because it is a parallelogram, we have alternate interior angles. Those alternate interior angles are formed by two parallel lines cut by a transversal, so they are congruent to one another. So I have another pair of angles. So I have congruent triangles by angle, angle, side. So let's start with the two sides that are congruent to each other. That was segment GH is congruent to segment IJ. And that's by definition of a parallelogram. This little symbol right here is the symbol for parallelogram. All right, the first pair of angles we said that are congruent are the vertical angles, and that would be angle G LH is congruent to angle ILJ. And that would be the vertical angle theorem. Right? So there's our first pair of angles. And our second pair of angles are the alternate interior angles. Angle HGL is congruent to angle JIG. So we can now say that the two triangles are congruent. Triangle GHL is congruent to triangle IJL. And that would be by angle, side. So because those two triangles are congruent, we can now say that GL is congruent to IL and JL is congruent to HL. Those are corresponding parts that belong to congruent triangles, therefore they are also congruent.